Unless you've been on vacation, you've probably heard about OpenAI's game-changing new model, O1 Preview. This release is sending shockwaves through the AI community. And today, we're going to talk about why technology such as Route LLM is more crucial than ever in light of this development. Let's break this down. O1 Preview is currently accessible via their chat interface, and API access is only available to Tier 5 users. And even then, it's limited. Experts are saying we've jumped from the intelligence of an average high school student to a PhD level with this release. It's a quantum leap in AI capability. Just look at the pricing screen from OpenAI. O1 Preview is quite expensive to use. When it's fully released, it's still likely to be considerably more expensive and potentially slower than lower tier models. This is where Route LLM comes into play and why it's about to become a must-have for businesses and developers alike. Route LLM tackles the dilemma of choosing between expensive, high-performing models and cheaper, less capable ones. Instead of routing every query to the most powerful and costly model, Route LLM intelligently decides which model is best suited for each specific query. The system is trained on preference data, learning from comparisons of model responses to various prompts. This training helps it understand which types of queries can be handled well by cheaper models and which ones truly require the prowess of something like O1 Preview. Route LLM uses several routing strategies. Similarity-weighted ranking. It assesses how similar a new query is to past ones and predicts performance based on that similarity. Matrix factorization. This technique learns patterns in how different models perform across various queries to make informed routing decisions. Classification models. Using tools like BERT and casual language models, it classifies queries to predict which model will likely provide a better response. As always, I encourage you to research this yourself, but some of the benefits appear to be significant cost savings without sacrificing quality, reduced cost by up to 85% on certain benchmarks, achieved 95% of performance of the most advanced models. Also, the ability to generalize, can adapt to new models and data without retraining. The Route LLM GitHub repository contains some great examples, but I found they were a little more complex than what I needed to show here. It actually took me a few minutes to get some of these up and running, as there are quite a few steps. Here's what the router chat example looks like. Let's just try it out. What is Thunder? Okay, and it knew to use the weaker model here, the Llama 3 8B, rather than using the GPT-4o model that we had specified as the strong model. It's a great example, but I decided to go ahead and put together a much simpler example so you can see how this works and more easily integrate into your code. I'll leave a link to the GitHub repo for this simple example as well. I've created a folder on my desktop called Route LLM /dev. This is on a Linux machine, by the way. This will run on Mac or Windows as well. Now let's get our hands dirty and set up Route LLM. First things first, we need to create a new Conda environment. If you're not already familiar with Conda, it's basically a package and environment manager. You can find more information and download it at anaconda.org. It's totally open source as well. So in the terminal, we need to do conda create -n, and then the name of our environment, route, and then python equals 3.11, hit enter. Now I already have this environment set up, but we're just going to overwrite it and just say yes again. All right, now we just need to activate our environment by copying this line here, conda activate route, pasting that in and hit go. Okay, now we're in our environment. So you should see your prompt change indicating the route environment is now active. Next up, we're going to install Route LLM. It's as simple as running a pip install command. I just typed in clear and enter to clean up my terminal. And then this is the next thing that we need to paste into our terminal. This command installs Route LLM along with some additional components we'll need. Now that we have Route LLM installed, let's set up our script. We'll start by creating an app.py file. Now we'll import OS so we can set up our environment variables. So our first environment variable we want to set is our OpenAI API key. You create that key on your OpenAI dashboard. And don't worry, I'll be deleting that key before publishing this video. Next, we'll set up our Grok API key. This one will be used for the weaker model, the Llama 3 model. And don't worry, I'll be revoking that key as well. We're setting up our keys for both OpenAI and Grok. This allows us to access models from both providers. Remember, never share these keys publicly. Now let's set up our Route LLM controller. This is where the magic happens. We're importing the controller from Route LLM and setting it up with two key parameters. We're using the MF router, that stands for matrix factorization, one of our Route LLM's clever routing algorithms. Then we're defining our strong and weak models. In this case, we're using OpenAI's latest GPT-4 variant as our strong model, and Grok's Llama 3 8B as our weak model. This gives our Route LLM a range of capabilities to choose from. Finally, let's look at how we actually use Route LLM to process a query. Here's where we send our query through the Route LLM. We're using the router-mf-0.11593 model, which tells Route LLM to use the matrix factorization router with the cost threshold of 0.11593. This threshold helps determine when to use the strong versus the weak model. I've created two example queries here, a simple one asking what is AI-driven automation, and a more complex one that's commented out. Finally, we're extracting the response content and the name of the model that was used, then printing them out. This lets us see not just the answer, but which model Route LLM decided to use for our query. I just noticed something. If you see this little yellow line under your controller, you just need to change your Python interpreter by going to View and the command palette, and then selecting Python interpreter and finding the environment that you have set with that. Now let's go ahead and run this. And we see right away that it used the Grok Llama 3 8B model, which is our weaker model, because it was just a simple question. Let's go ahead and close that. And let's uncomment our more advanced question, which is analyze the potential economic impacts of AI-driven automation across various industries over the next decade. So it's more of a multifaceted question. Let's take a look at the results on that. So it used ChatGPT 4.0 latest. It is quite an extensive response. So it works. And there you have it. With just a few lines of code, we've set up a system that can intelligently route our AI queries to the most appropriate model. This optimizes for both performance and cost. Make it an incredibly powerful tool as we enter the era of more advanced, more expensive AI models like O1 Preview. The emergence of cutting-edge models like OpenAI's O1 Preview is revolutionizing the AI landscape, but it also introduces new challenges in cost and efficiency. Tools like Route LLM are becoming essential by intelligently routing queries to balance performance and expenses. This innovation not only makes advanced AI more accessible, but also paves the way for more sustainable and scalable AI applications. I'm really interested in hearing your thoughts. Have you tried out model routing solutions like Route LLM? How do you see this technology impacting your projects or the industry at large? If you want to experiment with Route LLM yourself, I've included the GitHub repository in the description below. It has all the instructions you need to set up and explore this powerful tool. Before you go, let me know in the comments what you'd like to see next. Are you curious about more AI optimization techniques? Maybe topics like low-code or no-code technologies? Or integrations with other programming languages? Your feedback shapes the future content. Thanks for watching, and until next time, keep pushing the boundaries of AI.